Hello students, welcome to another session of pre-calculus. Today we will talk about functions, evaluating functions and finding domain and range of functions. Let us talk about a few definitions to begin with. A variable is the first one. A variable is a quantity whose value can take on any number within a set of possible values. Frequently used variables are x and y. A relation is something in two variables x and y. It is a set of ordered pairs x, y, which last class we call them coordinate pairs. A relation can also be written in the form of an equation, like y is equal to 2x plus 1. Okay? The domain is a set of x values in the ordered pairs, right? Or the set of all possible x values, that is our domain. The range is a set of y values in the ordered pairs. Now, y is a function of x if for each value of x in the domain, there is exactly one value of y in the range. That is, for one value of x, there is only one value of y. If for a value of x, there is more than one value of y, then that is not a function, okay? Let's talk about this a little bit more. The equation x squared minus 8x plus y squared plus 10y equals negative 37 is the equation of a circle of radius 2 and center for negative 5. Okay? Now, in this equation, x can take on any value between 2 and 6. These are the possible x values. This relation is not a function because you can have an x value that is related to more than one y values. So let's start at where x equals 2. When x equals 2, your y value is negative 5. But when we move to the right from x equals 2, let's pick something like where x equals 4. Notice right here, x equals 4 has a corresponding y value of negative 3 and also another corresponding y value of negative 7. Okay, so this 1x value can be paired with two different y values. Right, so we can have one x value to one y value, right, like 2 and negative 5, and an x value to more than one y values. That is why this is not a function. Right? A function exists only when one x value is related to one y value. If x is called the input and y is called the output in a relation, then a function occurs when an input is associated with only one output. So look at an example where this happens. If we consider the half circle, y is equal to negative 5 plus radical 4 minus x minus 4 parentheses squared. That is the upper half semicircle or upper top half circle, right? This relation is a function. Why? Because if you consider when x is equal to 2 right here, we had one value, negative 5. When x was 4, it's only one y value at negative 3. Right? And when x was 6, is one y value again, all the way. So each x value has only one y value. There's a test called the vertical line test, which we use to show that a graph is a function if we move a vertical line, started from the left, continue moving the vertical line to the right, and if that vertical line intersects the graph at only one point, then it is a function. And here you see that that is happening. So the vertical line test on the upper half semicircle crosses the upper half semicircle at only one point each time. So then the upper half semicircle is a function using the vertical line test. Okay, let's talk about evaluation of function. When we're evaluating a function, we see something like f of x is equal to, say, x plus something, right? Let's say x plus 2, something like that, right? This f of x means just f of x, not f times x. Okay, so we will need to keep that in mind when we're evaluating functions, right? We're not doing, like in this case, it's h of x, not h times x. Okay, so if h of x is equal to 4x minus 3, I want to find h of negative 3, so h of negative 3 will be equal to 4, input your negative 3 minus 3. Okay, so on this side is 4 times negative 3, which is negative 12, right? On this side, do not call this negative 3h, just keep it as h of negative 3. So h of negative 3 be equal to negative 15, and that is your final answer. Do not do anything more. You have fully evaluated. Okay, part B, h of negative 1 equal to 4 times negative 1, right? Minus 3, and that would be negative 7, right? So h of negative 1 is equal to negative 7, and we are done. Okay, that is it for evaluating functions. The next thing we will talk about is domain and range. Domain is all your possible x values. Okay, so domain is all your x values possible, right? All real x values, right? Your range, all your y values possible, right? So you can be given an equation, you can be given a graph, you can be given a table, you can be given a list of x and y values. Your domain in either case will be all x values, possible x values. Your range will be all the y values, right? So if you're given a graph with a set of points plotted on it, we want to do, like in part A, we want to write out all the set of points. So we write out negative 3, negative 4, negative 1, 3, 0, 1, 2, 4, and 4, 4. So that's all the points, right? For your domain, you'll find all the x values in order from smallest to largest, in order. Order is important, okay? No repeats. Negative 3, negative 1, 0, 2, 4. We're done, right? You arrange all the y values in order. Negative 4, next one is 3. But following that is 1, so we don't want to write the 3 before the 1 because you want to go in order. Next, we have a 4, and we have a 4. Write the 4 only once, right? And we're done. We're done with part A. Part B, this is starting at negative 3, 2, but this is not included. So we start at negative 3 and 2. Right, it's an open circle, means that it's not included. So that means that you're going to use parentheses for open circles. All right, so your x value will be all numbers from negative 3 and going right, okay? Going to the right. Right? So from negative 3 going right, that's all the possible x values. So your domain then would be negative 3 to infinity. Your range would be all the numbers from negative 2 going up, that's your range. So that's -2 to infinity. Right. Graph C, let's look at our domain. The domain are all the x values, but if you look at this blue graph, it ends here, feels like it's -1, but it's going to continue. Okay, so it will continue beyond -1 all the way to infinity. Likewise here, it will continue beyond the 5 all the way to infinity. So here your domain will be -infinity to +infinity. And your range, now let's look at our range. Our range, the top value is at y equals 4. Okay, the top value is at y equals 4. Because the graph passes through 4, then it's included. So we use a bracket. And then that is the top. And then it can go all the way down to -infinity. So it goes from -infinity to 4. So the starting value will be -infinity and up to 4. And that's stuff. Okay. For part D, we have what we call here a domain restriction. In this case, for a domain restriction, if this number is 0, everything on the bottom is 0, so it explodes. So your domain is all real numbers except where denominator is 0. Is 0, right? That means 2x minus 5 cannot be equal to 0. So it's everywhere except 2x minus 5 is equal to 0. So we solve for x in this case, plus 5 plus 5. So that's where 2x is not equal to 5. So that's where x is not equal to 5 over 2. So that is all real numbers except where x is equal to 5 over 2. Or you can say x is not equal to 5 over 2. So in interval notation, it's going to be, I think, from -infinity to 5 over 2, union 5 over 2 to +infinity. That's it for the domain. The range, we will deal with a little bit more in detail later, but for right now, I will tell you that the range is everything from -infinity to 1/2, union 1/2 to +infinity, and that is because of the first degree rational function here. That's 1x over 2x, so that's 1 over 2. That's where it would not occur. Okay, final one let's look at is where you have a radical, then the restriction is that anything under the denominator cannot be negative. Okay, so the restriction is that there's no negative, and that's for the domain. There's no negative on the square root. So let's work through this real quick. So this 2 minus x cannot be equal to a negative number, right? So that means 2 minus x must be greater than or equal to 0. So 2 must be greater than or equal to x, right? So your domain then would be, real quick, everything up to 2, from -infinity to 2, right? So that's your domain. Won't spend a lot of time on range on this, but we'll talk about that later on in class. That is it for this section. I'll see you in a couple of hours. Thank you very much.